it's first order, it's what function? It's the natural log. We went over that a ton yesterday. That was our third list we made, right? If you didn't watch the video, you will be super lost. It's okay. It was the integrated rate law. When you integrate the rate law, you end up with this long equation that we will go over today. And it actually turns out to be in the form of y equals mx plus b, which is the form of a line. And the ln of A versus T gives you that straight line. So it's the ln of the concentration of A at a specific time versus that time, all right, that it is linear. Okay, next. A reaction is found to be zero order in A, meaning A would be raised to the 0 power, which means no matter what, A is always going to be equal to what value? 1. Okay, that's ugly. So if I put a 3 in here, what does that equal? 1. What if I put a 10? 1. All right? So there will not be any change at all. It will remain constant. I could quadruple whatever number you want. I can put in there and there's no change because anything raised to the 0 power is always just going to be 1 no matter what. So we would actually say this reaction is not dependent on the concentration of A. The example I used for that before was magnesium solid plus HCl causes a reaction to happen. The concentration of this is important. The concentration of the solid isn't even a thing. We don't take the concentration of solids. We take the concentration of liquids and gases, or solutions and gases. So the concentration of Mg, if this was in a rate law, would be raised to the 0 power. Okay. All right. I am recording. Okay, next, I'll pause this. There are 2 separate questions here. Right here, they do fit. All right, so here we go. We addressed this a little bit yesterday. If the rate law is K equals AB2, which one of the following statements is true? Or false, I mean. K is the reaction rate constant. That is true, so meaning this is the wrong answer because it does say false. The reaction is second order in B. There's a 2 with B, so that is true. So that's wrong because it's not false. The reaction is first order in A. That's a true statement. The reaction is second order overall. That's our wrong one, correct? To find the overall order, you add the 2 exponents. Now, there isn't a 1 there, but if there isn't, there is. I know that doesn't sound like it makes sense. But that adds to third order overall. Okay? If B is doubled, the reaction rate will increase by a factor of 4. That is true, because 2 squared does equal 4. So, it is D. Not that bad, hopefully. Okay, and the last one. So the graph shown below depicts the relationship between those things. The slope of this line is equal to, more people get this wrong than you think they should on the test. It's negative K. Okay, you see A, sometimes you're like, oh, it's K, I know that, and you just circle it and you don't even read. Do remember that K is a positive value. This is a negative slope, so we take the negative of the negative slope to make it a positive value. Solid? Okay. That's just saying the reaction is going from 2 of A to C. Like it's, I don't know why they would just put such a random thing, because it doesn't really make any sense, but it doesn't matter. All right. Let's move on. Here we go. So now we're going to need a calculator. If you don't have it, there's still 3 loners. Once they're gone though. 1 loner, post. Okay. I may have an older one up in here. Nope, I don't know where it's at. Okay. So let's review. from now on, well, this one, it tells you it's a second order process, but whatever. From now on, you should put in both lists. Remember how I introduced that second list just for a second yesterday? What you should do, and it doesn't take more than 10 seconds, so you might as well just do it while you're in there. So you have your time versus your concentration. Then you want your LN data, and your LN, so if this is list 1, this is list 2, list 3 would be the LN of L2, okay? And then your last one, and we won't add another one over this, it's 1 over L2, okay? So will you populate that data in your calculator? Now, I know, and you know, because you can read, that this one is going to be a second order process, but let's pretend we do not know which one it is. And we'll walk through that entire process. First thing I would do would be to plot my L3 versus time. When you plot that on your graph, I don't have it in front of me, but you go to Calc. What do you do to plot it again? Second stat first, right? Yeah, and that takes you to your plots. You can set it to L1 versus L3, and then you graph it. Now, most likely, that doesn't look right. Hit zoom 9 now. Okay, there we go. Once you graph it, you end up with a line that just looks like this. Okay? It's curvy for sure. Will everyone show me that graph so I just know that you know what you're doing? Yep. Let me see there. That's okay. Something else is turned on, so it might be tricky now. And then this graph. Something's weird. There we go. Yeah, it doesn't have to be, but it helps you see it better. Okay. All right, so have that on your screen so I can check that you and I are on the same page. Good. No calculators? How do you know? Okay. So this is because you've had this in your algebra class. Turn that off. Hey, just real quick warning. If you get your calculator and things look weird, it's most likely because you have something from math already plotted. Okay? Then, the second thing, if you look at your calculator and it looks almost like nothing, that's because you got to hit zoom 9. Zoom 9 is where it fits the screen, it fits it to your window. Zoom 9 is like your best friend in this whole process, in my opinion. Okay. As I walked around, everyone has a line that is pretty much not straight. Correct? Okay. So, we know now it's not first order. So now go back to the graph, do everything the same, but change it to L4 versus time. And then graph that. When you do that, though, you won't see anything on your graph, because once again, you're in a different window, so you got to hit zoom 9 again. And then that line should hopefully be straight. And will you just keep that on your screen? I got you, Diane. Not straight, linear. All right. So now we can see that it is a straight line for this one. Correct? So if 1 over AT is linear, then we know it's second order. And we know that the slope is equal to K. Now, do we remember how to find the slope? Now that we have the graph, what do? Okay. Stat. All right. Then, most of you, it will do whatever you graph. The ones of you that have that old calculator, you have to make sure and set it the right way. Okay. Yeah, it looks like you have to change it to 1 and 4, but that's no big deal. So just make sure it matches the one you want, and then hit calculate. What does it say at the bottom? Okay. Yep. 5.54. Every time I do that, I do it. Because I'm a chemistry teacher. Well, usually what comes after an L? An I, because it's lithium. And I'm even writing it lower, like it's just a habit. Okay. We all right with this? It's not that bad. I mean, it's typing intensive, and it maybe is some memory, but it's not that bad. Okay, this is what we use it for. We use it to figure out the order for each thing. And I think, post where you like, I like the other way. Why do we have to do it this way, or essentially? Okay, here's the reason why. Because most of you probably do like it the other way. The reason why is because to do it the other way, you have to have a specific type of table. We are not given that table when we have to do it this way. They're two completely different data tables. So you have to know how to do both. Go ahead, Island. You could probably do the top 3 and call it good. It really is up to you. But yeah, it would be fine. Okay, I want to do one more. So, let's see here. We will go over how to use the math here in a second. But will you figure out that data, first or second order? Oh. Make sure if one of the lists you get is longer than the other, you'll get an error. So make sure you clear your data out and retype. L1 versus L4 gave you a slightly straighter line. And I still don't know, post, what's going on, because yours, it's like upside down too. But I checked every number, it looks fine, but whatever. Here we go. So, if this is the one that's linear, then we know it's second order. Okay, so we could determine the rate law. We would just say rate equals K, concentration of NO2 to the second. That's what we mean by the rate law. Now, write the integrated rate law. It is that. Now, that is definitely not, if you had to have that memorized, that would be an oh shoot. But these are things that are actually given to you. Both of them are given to you by me and by the AP testers. This is the integrated rate law for a second order reaction. Okay? C, determine the value of the rate constant for the reaction. All right. That was pretty easy before because we said, hey, K equals rate over that. All right? But we do not do it that way when we're given these. We have to solve for K here. Okay? It's a little bit harder algebra, right? It is, I promise you. All right. The reason we can't use this is because there's no real rate. So, K, we got to do all this crap. So let me bring that down and let's hopefully it's all together. I'm afraid of that. Oh, geez. How am I going to do this? Whatever. We'll take some of that with us. What time are we out of here? Okay, it's always bad when I'm like, how long do we have? Because then you know it's about to get real. Here we go. Thank you. So now we solve for K. So just make sure you do your math correct here. The first thing you should do to get K by itself is subtract this, correct? So I'm going to subtract, ignore the arrow, 1 over the concentration of A naught. Now remember, I'm a chemistry teacher. Sometimes I screw up algebra. Be patient, but don't wait till the end to call me out if I screw up algebra. Call me out at that moment. Okay? This is a minus sign. All right. We okay with that so far? Now, it is, Isaac pointed out, it's weird because it's really subtracting from here to there. But we'll rewrite the whole thing in a second, so don't stress too much. Okay. Then, all I have to do is divide by t, correct? That's the only algebra left. Okay. Now, I'm going to write this in the more correct format that you're used to, because we've always put our variable alone on the left, pretty much. So K is equal to 1 over AT minus, because we're going that direction, remember how I wrote it? I know it's weird. 1 over A naught. All right? And that is all divided by T. Okay. Now, we come up here, and we're going to plug all this crap in. All right? So I have 1 over AT. I can select whatever I feel like. I'll go here and here. Concentration of AT is 0.444. You can pick whatever row. It doesn't really matter. 0.444. I'm going to put this down here. That was at time 1200. Is that what it was? Okay. All right. Minus 1 over A naught. At A naught, we had 0.5. And I just do this math first. Then I divide by 1200. And that will give me my K value. That's a super good point. We're wasting our time. Because the slope dictates it to us. All right. Because I don't think sometimes. And we're going to use this equation for D, not this. But whatever. We're just going to rearrange stuff. I apologize. You could have found the slope. I warned you to call me out at the start, not the end. It's okay. We're still friends. Well, don't argue. It's fine. Because we have to be able to manipulate this for any of the variables involved. But good call. Okay. That's okay. All right. Now, I'll bet you $1. Check your slope. Oh, that's what you got from that. Okay. Check the math and let's see if our slopes match up. Okay. So, I just wanted to do that to prove to you that it's a true statement. I win. It was the same. So now we know math and math are true, and I want to bear that testimony to you. Now that we've proved that, what I really want you to do is solve for D. Are you ready? Okay. I'm going to erase all this. And now, we're going to calculate NO2 at 2.4 times 10 to the 4th, correct? So, is that A naught or AT? That's A at a specific time. All right? A naught, I know already. That was 0.5. You okay with that? So, should we do the whole algebra? Yeah. Are we okay if we just change this whole thing to a 2? Okay. It's okay. Watch. This is 0.5. 1 over 0.5 is 2. And that's just going to be easier to write the whole time than all of that. The 0.5, A naught, means the concentration of A at time 0. It's right there. Okay, is everyone okay with the 2, where the 2 came from? All right, so yeah, it's the initial concentration. So now 1 over AT concentration is equal to KT plus 2. We okay with that? So I'm going to subtract 2. All right, and then we would take all that and divide it by T. No, hold on, we're solving for the wrong thing. I got to pull my head out of my butt. Here we go. I apologize. That's because I'm ruining your life. All right. I have feelings. Okay. This is what happens when I have early morning meetings and I don't double check my math before I start talking out loud. We are trying to solve for this. Now, here we go. So we are going to multiply both sides by AT. You with me? Now, trust me. Then you divide 1 by KT plus 2. Okay, because we're technically algebra, you have to go over, then bring the other piece under. With me on that part? Okay, so we had this. So now I take 1. I divide it by KT plus 2, and that equals the concentration of A at my time. It's still a factor. It's all wrapped in here. Like we could first outside, inside, last, but we don't need to because we're going to take it right back over. So it's just a thing. Now, if you want, you can plug in every number at the start, and then it's probably even easier. So here we go. We just plug the stuff in now. We have 1 over K, which was point what? How many zeros? 2, 1. Times the time is the new time they gave me in the problem, which was 2.4 times 10 to the 4th. So is that 24,000? Okay. And then I'm going to add 2. And that will be equal to my concentration of A at a specific time. Now, make sure you do your order of operations correctly here, because we could probably get 6 or 7 different numbers, even though you all type it in, you think the same. This entire process on the bottom needs to be done before you divide 1 by that answer. What do you end up with? 0.14? That's all right. All right. Now, I had, Chelsea and I, we've had a rough rocky relationship once in a while because she doesn't show up sometimes. But a minute ago she said, this is so pointless. No. This actually is important. And I know it seems like, wow, this is really random. But, and I'm not going to say that any of you are going to be chemical engineers, but some of you might. But if you are a chemist and you need to produce something at a certain period of time, you need to know what that will be. You need to know how to get that right on the spot, so you can get exactly what you want. The example we use on all of this typically is an airbag. You need to know exactly what the concentration or the mass or all that will be at an exact fraction of a second. You need to know, and if you're off a little bit either way, the airbag's either going to kill you itself or you're still going to hit the steering wheel. Okay, so it seems weird, but knowing the concentrations at specific times or knowing the times that you need to get certain concentrations is actually, chemistry-wise, it is a really important idea. Now, math, it seems like, what the, but trust me, this, in chemistry, this is one of the more important things. Now, this is it for second order. And we're going to spend the rest of today, I don't know, I actually won't be here the next 2 days. Love you, hashtag goodbye. But we're going to make sure that we're good at the algebra. Okay? First order has a different integrated rate law because of calculus. You deal with a 1 exponent in calculus different than you do a 2 exponent. So they have different rules, but they're still the same idea. We have a concentration of whatever we're talking about at a specific time. We have a rate constant. We have a specific time. No, this I should say again, this is not multiplied here. That's lowercase, and that's lowercase. You okay with that? Like they're not variables. We're just saying concentration at a specific time, but we do put in time here. Then we have the ln of A naught. So we can do this for both the first order and second order. It doesn't matter, but you need to A, know which one to use, and then B, how to do algebra correctly. You okay with that? All right. 5 minutes, 4 minutes, 10 minutes, 4? Okay. Let's come back here for a second. No, it was that other direction. I'm sorry. All right. I don't know. We don't have enough time to do a problem. The principle's right there though, so I don't want to look like I'm wasting time either. But this is the sheet that I give you on the exam. It's way more than the AP test gives you, but it's good enough. It will tell you, hey, these are the 3 main orders that we talked about. It will give you the overall rate law, which that one's easy. Then it gives you the integrated rate law. And this looks weird. You're like, well, there's 2 of them. Actually 3. They're the same. They're just rewritten. Okay? They're just algebratized or whatever. Then there's the other one. I will warn you, one big mistake here is it gives you negative k, and you found your slope, and it was equal to negative k also. Okay? When you find the slope, and it's first order, this is the slope because that negative's there. Don't turn it positive because k is positive. That sounds weird. I just read your eyebrows. That sounds weird. So one more time. K is equal to the negative slope. But in this reaction, I'm asking you for negative k, which is the slope from the graph. So all I'm saying is don't do it twice. And like, don't think, oh, well, it was negative, so now it's a positive. No. It is the negative value of k. That's one of the biggest mistakes you make. All right? This information we are rock solid on. Hopefully, straight line, that tells you the slope. Half-life. You're most likely, You're just going to watch last year's class video presentations tomorrow. I am not going to answer that question.